So, oh, did I just mess it up now? No, we're good. Alright, today should be all review. We are practicing factoring again. How many of you remember doing factoring? Algebra's hand should be up, because you did it, I believe, in algebra and in geometry. So, there are multiple different ways to factor. Some of you probably use the box method. Some of you probably use guess and check. Some of you probably do factoring by grouping. Some of you probably do like the star method or the X method or whatever method you use. There's a million of them. Whatever method you use it, right? I'm not going to tell you have to use a certain method. Now, I'm going to use guess and check 99% of the time, just because that's what I know and that's what I'm comfortable with. But that does not mean you have to do that. Alright? So you use whatever method you're comfortable with. I'm going to show you two methods. I'll show you one problem with the box method today and probably a problem on Monday with the box method. Then I'll show you guess and check, and that's one that I'm going to use. Alright? Like I said, though, if you have a different method that you like, that you're comfortable with, then use that. So, oh, it's all messed up right now. Shoot. Alright, so in order to simplify rational expressions, we must remember how to factor them. That's what we're going to spend today reviewing. We're actually spend 3 days doing factoring. Today, we'll talk about where it's just x squared. On Monday, we'll talk about where there's a number in front of x squared. And then on Tuesday, I will not actually be here. Those visitors are coming through our schools on Tuesday. They won't come into our hour, don't worry. But I've been asked to go around to the other schools and actually see the stuff that goes on and what they do on those days. So I'm out of the classroom. So we were supposed to play factoring bingo. Mr. Weitzer is the sub.
Oh God!
Dang! What? He actually makes you guys do things.
Who's Mr.
No. Oh! I hate that when I have to do things.
The old guy. The old guy with the glasses.
Yes.
Hey. All right, listen. Listen. So we were supposed to play factoring bingo, but I may just have him hand the worksheet out and you guys work on it. Is that okay with you guys?
Yeah.
Okay. So we'll probably do that, and I'll be back Wednesday and we'll start moving up the unit again. Okay? Alright, so first and foremost, when we're factoring, the first thing I should always look for is to see, can I pull a greatest common factor out? That is the first step in any factoring problem. Can I take out a GCF or greatest common factor? Like, in example 1, I have 2x squared y minus 6xy squared. If I look at 2 and 6, is there a number I can take out of both of those? 2. If I look at x squared and x, there's something I can take out of both those?
2xy.
Just x. And then y and y squared I can take out a y. So I'm going to factor that out. If I can factor things out, I'm going to do that. The first one, all I'm left with is an x. The second term, I'm left with 3y. Right? I took a 2 out of here, I was left with 3. Took an x out, so it comes out. Took a y out, I'm left with y in that second term. That's it. That's all I had to do. Hey, is there a way I could check that answer to make sure it's right? Abby?
Could you fill in numbers for us?
You could. That'd be one way. Another way would be we could just distribute it back through. And if I distribute it through and I don't get what I started with, I did something wrong. Alright, so if you ever want to check your answer, distribute it back out. Alright, the second one, 9x squared minus 27x. Well, 9 and 27, is there anything you can take out of those? 9. X squared and x. X, good. I'm left with x for my first term minus 3. Right? Does that make sense?
Yes,
sir.
Do we have any questions on that?
Yes, I do.
Okay, I'm going to... The next one says you try, but I'm going to do it. I just want to keep going, get as much work time as possible. We have 10x cubed plus 15x to the 4th plus 20x to the 7th. Now, I need to be able to take it out of all 3 terms to factor it out. So if I have 10, 15, and 20, I can take a 5 out. If I have x cubed, x to the 4th, and x to the 7th, I can take out a x to the what power? 3rd power. Good. This first part, 10 divided by 5 is 2. I took 3 x's out, so I'm left with just 2. plus 15 divided by 5 is 3. I'm left with 1x because I took 3 of them out. The last part, 20 divided by 5 is 4. I had 7 to start with. I took 3 out. I'm left with x to the 4th. That's my final answer. That's it. That's step 1 in any factoring problem. Take out a GCF. All right? Any questions on that?
No.
Ms. Baker?
I thought when you added parentheses, you multiplied that.
No, so if I have like x to the 3rd to the 4th, that's when I multiply them.
Oh, okay.
Right? If I'm just multiplying these two pieces, I add them. Okay? Good question. Oh, what I do? I keep forgetting that this isn't lined up for some reason. Alright, second step. Figure out, do I have a difference of perfect squares? Well, let's think about what that means for a second. What does the word difference mean in math? Subtraction. So first I need to look for, do I have subtraction between two terms? Then the second part of that is perfect squares. What's a perfect square? A what?
A number times itself goes into a perfect square.
A number times itself goes into a perfect square, but I want to just limit it to numbers. Right? Like all of these are perfect squares because it's 2 times 2, 3 times 3, 4 times 4, 5 times 5. They all make up perfect squares, right? But wouldn't x squared be a perfect square as well?
I think so.
X times x give me x squared. Wouldn't y to the 6th be a perfect square as well? Because y to the 3rd times y to the 3rd, I would add my exponents. I get y to the 6th. Yeah. So anytime I multiply something by itself to make a new number, that makes a perfect square. So if I look at this first example, do it all day. X squared minus 25. First of all, is it a difference? Do I have subtraction?
Yes.
Yes. Do I have two perfect squares?
Yes.
Is x squared a perfect square? Yeah. Is 25 a perfect square? Yeah. So to factor it, it's actually going to be really easy. What we're going to do is we're going to take the square root of both terms. Square root of x squared is x. And that's going to be my first part. Square root of 25 is 5. That's my second part. One of them is addition. One of them is subtraction. That's our answer. That's our factored answer. If I foiled this, what should I get? I should get the same thing, right? So to check your answer, if you want to foil it, you should get the same thing.
Doesn't matter if the subtraction or addition is first.
It does not. As long as one of them is addition, one subtraction. So if I look at the next one, 16x squared plus 25y squared. First of all, can I factor anything out? Remember, we should be checking that. Not in this top one here. Do I have a difference of perfect squares? Do I have a difference or subtraction?
Yes.
Do I have subtraction?
Yeah.
Yes. Do I have two perfect squares here?
Yes.
Yes.
Yep, 16x squared is a perfect square and 25y squared is a perfect square. So I'm going to do the same thing. I'm going to take the square root of both terms. What's the square root of 16x squared?
4x.
4x.
5y.
Square root of 25y squared? 5y. And remember, we're adding one, we're subtracting one. Once again, if you want to check it, you can foil it. Alright. Like I said, the next one says you try, but let's try it together. It is kind of a tricky problem.
Perfect square. 2. 1.
Okay. What should be the first thing I ask myself?
Greatest common factor.
Greatest common factor. Do I have a greatest common factor I can take out?
2.
2. So let's do that. 2 times x to the 4th minus 16. Alright, took out a 2. Well, now what should I do? Hold on, hold that thought. This is Eldridge. Hey. It is. Okay. Okay.
Same to the
that'll work.
office.
Thanks.
I'm just wondering.
Alright, so what should be my next step then, after I factor out the 2? No one knows?
Wait, hold up.
What were we just practicing this whole page? What's the thing called? Difference of perfect squares. Do I have that? Do I have subtraction?
Yes.
Yes. Is x to the 4th a perfect square?
X squared.
Yeah, because x squared times x squared gives me x to the 4th.
And then 16 is 4.
Oh,
And
X
16's a
squared.
perfect
Oh,
square.
I see.
Alright, so I can do the same thing. Make it a difference of perfect squares. Square root of x to the 4th is x squared. Square root of 16 is 4. Add 1, subtract 1. Am I done there?
No.
You have to distribute.
Why not, Bryce?
Because you have to distribute.
Not going to distribute. Not going to distribute. So I like the answer of no. I like that part. But we're not going to distribute. Carlina?
X squared is still a perfect square.
X squared is still a perfect square.
Oh, you have to take the
And
square.
so is 4.
Take the square root.
I have another difference of perfect squares up there.
Oh, yeah, that.
Wait,
So
you
I
have
can do it again.
Oh.
So I get 2 times x squared plus 4. And that second part is going to break down as well. It's going to factor as well.
X and 2, X and 2, too. Okay.
X and x, because x squared, the square root is x. And then 4 is going to be 2. So plus, minus. Guys, you need to factor as far as you can. Keep going. Double check. Can I factor anything else? Yes, Ms. Baker.
Why do you still keep the x squared?
Yeah, can you just have
Yeah,
the,
yeah,
can you just
yeah.
have the 2 like
Hold on though. Because is this a difference of perfect squares?
No.
So can I factor this?
No.
Wait,
No, so that stays there. Right? Because if I foil this, and then I foil it back, I still need to get back to where it began with. I can't just let it disappear. Right? But I can't factor it as well.
Oh, because X squared.
Because if I do the same thing I just did, I'm going to end up with x squared
X
minus
squared.
4. Right? Does that make sense?
Yeah.
I
Abby?
think so.
You think so? Like if you wanted to factor that, what would you factor it to?
X plus 2.
So you want to do x plus 2 and what?
X minus 2.
And x minus 2?
Isn't that right? Yeah.
I know, I heard someone else say it though. But if I FOIL this out, I get x squared minus 4. Is that the same as x squared plus 4?
Oh, so you only do it with the...
No, you can only do it with the subtraction. That's why we call it a difference of perfect squares.
Oh, so you do it until it makes no sense.
Hold on. Alright, if that works for you, yeah, whatever you said. Okay, yeah. So, it can only happen when we have subtraction in the middle, guys. It's a difference of perfect squares. It's not a sum of perfect squares, it's a difference. You good?
Yeah.
Okay, do you need a pass back to study hall?
So you
You're doing a lunch, you're in lunch. Okay, perfect.
Sure,
Thank you, Andrew. Alright, so that's our final answer. Keep factoring until you can't anymore. Any questions?
No.
Alright, should we keep going?
Yeah.
We have 6 problems to
I
do.
got this on.
I missed, I did it again.
Just do 4.
Alright, then if it's, okay, so if you factor out your GCF, if you try to do difference perfect squares and that hasn't worked yet, then you go to our normal factoring. Our box method, our guess and check, factor by grouping, diamond method, whatever method you use, there's a million of them. Now, the first one I will do with box method, and then everything else I'll do that today, I'm going to do with guess and check, just because that's what I use. Right? Do you have to use that?
No.
No. Use what you're comfortable with. So the first one, x squared plus 11x plus 24. If I do the box method for that, if you remember, box method. Right? We take our first term, that goes in the top left, 1x squared. Take our last term, goes in the bottom right. I take the number in front of x squared, which in this case would just be a
X.
1.
1.
Right? It'd be 1x squared.
You have to write one X or kidding.
Right? You don't have to write 1x squared, but you take the number in front of x squared, and we'll see this on Monday. When we have a number out there, it makes more sense then.
Alright.
But you take 1 times 24, which gives you 24. And we're going to list our factors of 24. 1, 24, 2 and 12, 3 and 8, 4 and 6. We need to figure out which of those factors will add to positive 11x. 3 and 8. Right? 3 plus 8 will give me 11. So I put those two terms in the other two boxes. It doesn't matter which one goes where. It doesn't matter if the 3 goes top right or the 8 goes top right. They just both have to go in there. So then I factor out the GCF for each row and each column. So the first row, x squared and 3x, the GCF would be x. The second row, 8x and 24, the GCF would be 8.
And then 3.
The first column, x squared and 8x would be x. The second column, 3x and 24 would be 3. So I get x plus 3 and x plus 8. And that's my factor part. So that's using the box method. Like I said, you do not need to use the box method. It is not necessary. But you are allowed to. Okay? Example 2, x squared minus 6x plus 8. I'm going to do guess and check. Alright? So if I look at x squared, the only thing that's going to make x squared is x times x. So I know I'm starting with that.
What's a negative 6?
I need to figure out what multiplies to a positive 8
Oh,
adds to a negative 6.
negative.
Negative 4 and negative 2, right? If I look at the factors of 8, I can choose either 1 or 8. 4 and 2. Multiplies to 8, adds to negative 6. So I get minus 2 and minus 4. And that's my answer. Now, is there a way to check our answers? Yeah, what do you do?
Distribute.
Well, FOIL, right? Distribute, FOIL, same thing. FOIL it back out, and you should get what you started with. Alright, let's look at example 3. X squared plus 2x minus 24. I get x and x. I need to know what multiplies to negative 24. So if I do 24, 1, 24, 2 and 12, 3 and 8, 4 and 6. So it multiplies to a negative number, which tells me that one of them has to be positive and one of them has to be negative, right?
Negative 4 or 6.
Yep.
Multiplies to negative 24, adds to 2.
6, negative 4.
Negative 4 and 6, or 6 and negative 4.
This one's
Does it matter which order you put them in?
No.
No. That's a good answer. Alright, example 4. Ooh. What's my first step in example 4?
greatest common factor.
Take out a greatest common factor, right? The last 3 we couldn't take out a greatest common factor. This one we can.
Docent.
Take out 2.
Yeah, x squared.
X squared minus 11x plus 10. Good. You took out the 2. Phenomenal. Now factor what's in the parentheses.
Negative 1.
So I'm looking here. Right? It's just x squared, so it's just x and x again. Hey, if it multiplies to a positive, but adds to a negative,
They're both negative.
they're both going to be negative, right? Negative times a negative is a positive. When I add them, it gives me a negative.
So smart.
So x minus and x minus,
Negative 1.
well, what multiplies to 10 adds to negative 11?
Negative 1.
Negative 1 and negative 10. Very good. So minus 1, minus 10. That's our answer. Alright? Any questions? Alright. Try the last 2, please. Try the last 2. Once we're done with that, we're done.
Is it add to 36? Is what adds to 36?
I don't know what multiple.
Can you do that?
36?
What if these guys want to do it?
36 back.
If none of them want to do it, then you can.
Okay,
You know?
well, I'm gonna write.
What?
I'll write for it.
No, they can write on their own.
Shit, what is
They're big boys and girls.
I know one.
They can figure it out.
I know one of us.
This is for them.
it? Is 6 and...
Add to 15. What other 36?
Nope, it'd be multiplied 36, add the negative 15.
Write that.
Something want help?
X minus 10. Alright, this one is x. 8 and 6. Yep. Next one is x plus 8, x minus 6. You're welcome. You're fucking welcome. X plus 8, x plus 6. Or x plus 8, x minus 6. It's one of the two.
X plus 8.
It's one of the two.
Yeah, but if you multiply,
So what factors of 36? So what multiplies to 36? That would add the negative 15.
it's going to be 16. That's what we're looking for. It's going to be 16.
So sometimes it's easier for you to like write out the factors.
Does not add.
It's
It
16.
might make it a little bit easier.
It's 16.
Hey guys, like I just told Jacob, if you need to, yo, listen quick.
It's 16 and negative 2.
If you need to, right? We're looking for what multiplies to 36. Maybe write out the factors of 36. That might be the easiest thing, right? If you can do it in your head, go ahead and do it in your head. But otherwise, write the factors out of 36. Do we have any volunteers to put them on the board?
Yes.
We do?
I'll do the first one.
Uh-oh.
I can do this. Oh, I can do the second one.
Oh my goodness. So we have 4 volunteers. Hold on.
Let him do it.
No, Sim.
Wait, what was
So,
that?
who wants to volunteer to put one on the board?
I'll put one on.
All right.
I'll just tell you the answers.
So there's 4 over here. So you need to pick a number. Hold on. Pick a number 1 through 20, and the closest 2 will get to do the problems.
Go.
6. 16.
10. Yeah, right in the middle. Can't go wrong with that.
8.
Yeah, you can't go wrong. You can't.
Sim, you get to do 1.
Yeah.
Abby, what'd you say?
16.
Okay, and you said 8. Okay, Carlina, you're out. You guys tied, so you need to pick another number between 1 and 10.
7.
You're going to go low, too.
Can't get to the other one. The first number was 12. The second number was E.
What's that?
E. Remember we did logs? E was like 2.71. Yeah.
You're so funny.
Wow, Baker.
Sim,
I don't even gotta put all that.
I like that answer.
You know what?
I like that answer.
You like that answer?
I like that.
You do it?
Yeah.
Sim is wrong.
I'm right. That's what I got.
Yeah, that's.
I love it.
You able to fit it? Alright, let's look at them. So, first one multiplies to 36, adds a negative 15. Right? Multiplies to a positive, adds to a negative, tells me they both need to be negative. So if I'm looking at factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Shh. I'm looking to see what adds to 15. In this case, it's 3 and 12. So I get x minus 12, x minus 3. The second one multiplies to negative 32, adds to positive 14. Shh, guys, quiet. So it tells me one of them is positive, one of them is negative. It tells me the bigger one is positive because it adds to a positive. So factors of 32, 1 and 32, 2 and 16. 3 is not a factor. 4 and 8. That's it. So I'm looking to see what adds to positive 14. Well, 16 and negative 2 would, so x plus 16, x minus 2. Awesome. Any questions on what we did today? It should have been a review. Do we all have some sort of method that we like to use for factoring?
Yes.
Okay. All right, cool.